All right, here we go. Good afternoon, everyone, and welcome to Improving's virtual Lunch and Learn. Before we start, please make note of the question mark icon at the upper right corner of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send questions to our moderator. Your questions will be delivered to our presenter at the appropriate time. We are excited to present Mark Runyon, Principal Consultant at Improving, who will be sharing going serverless with AWS Lambda. Mark?
Thank you, Will. As you said, we are looking at serverless today, and in particular AWS Lambda. We are going to be looking at all the benefits and why we would want to choose this option for our app development, especially when we are talking about the cloud and all the services and great things that we can tap into there. So to get started here, as Will alluded to, my name is Mark Runyon. I am a principal consultant with Improving. I also am a contributing writer for InformationWeek in the Enterprises project. I tend to write on topics around IT management, app development, DevOps, and most recently, a lot around artificial intelligence. So if that's something that interests you, I do have an article coming out next week around the limitations of machine learning and artificial intelligence for InformationWeek. So please check that out. Around application development, I have been working in the space for 20 years, and I have worked with both the AWS and the Azure clouds with clients. And through our partnership efforts, I became an AWS developer, certified developer associate about 2 years ago. Excuse me. And that partnership effort has been a very interesting exercise. We had to jump through lots of hoops and qualify a lot of stuff with AWS and our rep with Amazon, and very eye-opening experience all the way around. We don't really have time to get into it today, but for those who are interested, please reach out. It's an interesting discussion to have if that's something that you are looking to embark on for your organization. So to kick things off, we are not only looking at AWS Lambda, we are also looking at serverless as a whole. So, what are the features and what makes serverless something that we need to pay attention to and that we need to really take advantage of in the days ahead? And then specifically, we'll dive into Lambda and get a feel for its history, what languages are supported, and what other AWS services can it tap into. And then we want to back up a little bit and look at some of the sort of groundbreaking companies that are really using Lambda to great results and see what those use cases look like, and kind of to give us some ideas about how we could impact our own organization via piggybacking off guys like iRobot and Netflix and some of these heavy hitters. And finally, we're going to do a couple quick demos. First, using Visual Studio to publish a Lambda function up to AWS, and just to kind of show you how easy it is to work within that interface if you are from the Microsoft persuasion. And also just to develop a little CRUD app API using Python. So yeah, let's get us kicked off here. So first thing, what is serverless? If you listen to the name, it kind of fuzzies things up, unfortunately. I'm not a huge fan, but I'm sure they're not concerned about what I think about their naming conventions at AWS or any of our other cloud providers. To say serverless would kind of imply that there are no servers, and nothing could be further from the truth. We're not actually running in mythical clouds up above us. There are servers, there are racks. This stuff is actually running on hardware up in AWS. What they're trying to get at is basically all of the infrastructure and the hardware, and those pieces are really outside of your control. AWS is taking all that responsibility on. So you are not concerning yourself with patching the OS or licensing problems, and you are not concerned about having to provision all these servers to handle Black Friday, or something like dealing with the scaling and and the headaches and the hassles that come along with traditional, on-prem type development, which can still apply even if you're in the cloud. So you're running in EC2 and you're trying to come at this. You might come at it via containers or some other route, but even that has limitations that serverless does not have. So it's a really interesting development in the app dev space, and it's really kind of a hallmark of application development in the cloud. So it's really important from the perspective of this is where everything is going, and from a from just a usage standpoint, 80% of AWS customers are running Lambda, and 80% that are running containers are running Lambda, and then 50% of the entire AWS customer base is running it. So it has had a very quick adoption rate, and it has been very successful for AWS. So again, this is event-driven cloud computing. So something is triggering that Lambda function, whether it be an update to DynamoDB, or maybe a file gets dropped into S3. Maybe it's just a standard endpoint that you're hitting via, the API gateway. So there's lots of ways to get at it. There are about 30 services in total, AWS services that work with Lambda. So there's lots of use cases that you can make work for this. If we look at, let's go next to, why exactly do we want to use serverless? We've discussed a few of these, the no maintenance aspect, but the cost model is really interesting. So it is a cost matches usage model. So we're only paying for the compute time that we consume. So unlike having a fleet of VMs out there, we're not paying for that unused time at 2 a.m. on a Tuesday night. We are only concerned about how many times we're actually hitting those functions and spinning them up and putting them into use. So, and the pay per execution cost is 20 cents on your first million. And as you can see, 0.0001667 per gigabit second of compute time per execution. So given your application, this may be a very enticing way to sell this to management or whoever you're trying to pitch the solution to, of potentially this could be a huge cost saver for us. I do want to caution that in not all circumstances will you save money with serverless. Depending on your application, which you have to sort of surmise for yourself if it makes sense, serverless may not be a great option for you. Maybe you have long-running requests, and maybe you just have huge, heavy usage, and this pay per execution model just doesn't quite fit. Usually, you can find ways, architecture-wise, to come at it and kind of make it fit. But it is something you have to analyze and look at going into, does this make sense for my application? If we are, say, looking to rewrite an application, or if we're starting from scratch. We mentioned the effortless scaling side of things. So we don't have to concern ourselves with, spinning up new VMs and preparing our environment to handle masses of traffic that could potentially be coming at us. And you never know in life, there are expected events where you're going to get a hit, but there are other times when all of a sudden out of the blue, you get hammered, and you have to be able to handle that. And that's the nice thing about serverless and the cloud in general. You can effortlessly scale up. Performance is always optimized, and AWS is taking care of all of that on their side, and you're not worried with that. You are just focused on what you do best, which is writing code and making sure that your application is as effective and efficient as possible. So looking at flavors of serverless. When I say flavors, most cloud providers have their variation on serverless. So even if it's, say, IBM or Salesforce or Alibaba, just about everybody under the sun is a cloud provider these days. For better or worse, I'm sure that their customers all think for better, but There are certain, we're going to really just focus on the top three big dogs. So that'd be AWS Lambda, Azure Functions, and Google Functions. So when looking at AWS, all things being equal, if we were looking to choose one of the three of these, what is the argument for AWS? So its key thing is, and we'll go into a little bit more depth in the next slide on AWS, is it is the first mover in this space. They created serverless really to run their Alexa product. They had a need within their product community to create an engine that could handle the massive volume that was getting ready to get sent via all these voice requests. And they didn't have a great solution. So they developed Lambda to handle that. So it's kind of cool how it all kind of came to be and the origin story behind it. And that has kind of made them an innovation leader in the serverless space, because for one, they had a 2-year head start on Azure on serverless. So they were really able to, that's huge in the technology space. I don't have to tell you that, but they were really able to get that head start and make a huge foundation of their customer base in serverless before Azure even really had a chance to hit the ground running. So from the aspect of language support, they do support some experimental languages, stuff kind of like Haskell and Elixir and Rust. They are not officially supported, but they are kind of out there available for use. When we turn our notice over to Azure, they do have more official extensive language support. So PHP, TypeScript, F#, basically everything within that .NET Core suite. But again, they have come a little later to the party. The nice thing with Azure is they have really committed themselves to the cloud space. And so any innovation that AWS makes, usually Azure is right behind them on their coattails, and they have whatever feature that is coming up in the next release. So any advantage that might be gained in the short term by AWS, you can almost guarantee that Azure has something in the works to counter that and to make sure that they're not really falling behind in this space. So truthfully, both of these options are great serverless options. I would never dissuade you from using either one of these. We've used them both for clients, and they've worked really well. Google, not to dissuade you from using Google, but Google does have some limitations that AWS and Azure don't. At last check, they only supported Node.js and Python. So if you're not a Node.js or Python developer, that's going to be pretty limiting for you. They've had a very slow product development cycle on the serverless side. So they've gone a year between updates at times, which is huge. I mean, you can't really have that much lag in the cloud space. And they've sort of adopted more of a niche type product space in the cloud. I think they've kind of seen that's where they do really well, and that's where they can kind of make a footprint. So not to dissuade you from using Google Functions, but it does have some limitations that both AWS and Azure don't have. But regardless of which one you're looking at, the key here is to really look at your environment. So are you running on AWS already? Do you have services running up in Azure? Depending on that answer is going to really dictate which one of these makes the most sense for you. So that's not to say that you can't sort of run cross platforms. One of my colleagues, he did a really cool demo. It was about a year ago, where he wrote an Azure function to run an Alexa service. So he walked us through how to sort of tap into it and how to make those hooks work. But while it can be done, it takes a little extra lifting to make it happen. Whereas if he had gone straight from, say, a Lambda function to the Alexa service, it would have been fairly seamless between making that happen, because everything's underneath that AWS umbrella. So my only My only caveat here is basically to say, look at your environment, see what makes the most sense for you, and sort of stay within your ecosystem. If you adopted AWS or you've adopted Azure, you've really committed yourself to that platform, and you really need to take advantage of the services that are there for you. So imagine that we don't have a cloud provider, and we're starting here from scratch. And serverless is one of the main reasons that we want to go to the cloud for those efficiencies and what we think we can attain via this new technology. Why would we want to choose Lambda? So we discussed their sort of lead on innovation. So they had a product behind this, which is why they created this product. And they released it in November of 2014 at the reInvent conference, basically to say this product was developed for Alexa, but it works really well, and we think our user community within AWS would really like this and find it hugely useful for other use cases. So so they did get that to market, a couple years before Azure came along, and doing so, they were able to secure a very strong user base. So at last check, the number of users running serverless through AWS is 70%, which seems really, really high. But if you consider the cloud market share of AWS versus Azure, 32% versus 17%, that number does seem in line. Considering the first mover advantage, considering market share, that does match up. Now, with that said, Azure is making great strides on the market share side of things. They are growing faster than AWS, so we will probably see those numbers come down over time. But for right now, they have a pretty strong advantage in this space. So, doing a quick look at the history of Lambda. So as I mentioned, it was brought to market, or brought to reInvent in November of 2014. It was hit general availability in April of 15, and blueprints and testing, easy creation of testing functions came along a few months later. And then the key is the language support. So if you, kind of like what we're talking about with Google, if you don't really support any languages, then it's tough to convince the development community to get on board with us, and we are the vehicle that you need to use for serverless. So they've been really diligent about bringing new languages on at a nice clip. So Java came on right around the time that this was launched, Python a few months later, Node in early 16, Go, Ruby, and recently PowerShell. So they really have a nice broad reach when it comes to what is supported. Which brings us to to looking at what those supported runtimes are. And it's an interesting thing. So when I originally developed this presentation, it was probably about a year ago for the Atlanta Code Camp, and then I gave it again back in April of this year for a user group that I run. And the interesting thing was to start sort of research, okay, what has happened in the last 6 months in the space of serverless? And there has been lots of changes. This slide is one, and there's the provisioned concurrency model. And it was very interesting that everything in the cloud, and especially serverless, runs at kind of breakneck pace. That I tell you everything today of how things are, but tomorrow things may have changed, and maybe they've opened up new languages, and maybe some of the problems that were there before are no longer problems anymore, which is what we'll see here with the cold start issue. So it pays to stay on top of this stuff and to really kind of key into if we're going to adopt serverless and we're going to really sell our organization on it, we need to keep up with the advancements and recognize, okay, well, this is a problem today, but a month down the line they may have a solution for us. So in looking at language support, so one of the big things, like I say, about a year ago, was this issue of cold starts, and depending on your pricing model, it can still be a big concern. So Looking at something like Node.js or Python has a very lightweight runtime. So cold starts are kind of minimized, and you have an advantage there with those two languages. If we're looking at the other end of the spectrum, like Java, that has a very high memory footprint, long execution times, and so when we think about our between the cold starts and our pricing model of how long that execution time takes longer, therefore it may cost us more to run our application in Java. These concerns start to come up, and when I talk about cold starts, basically it's that initially hitting that function and having it ready to go on basically a no latency or a very fraction of a millisecond type response time. If we are looking at a cold start, that would be if I haven't hit that function within 15 minutes, it kind of goes dormant and it's kind of waiting for us to do something to hit it. And at that point, we have to kind of reinitialize it and get that thing going again. So hearing this problem, AWS has developed a concurrency provisioning pricing model, which we'll go over in a second, that kind of tweaks the cost, but does make sure that if cold starts are a concern for your organization or for your application, or maybe even functions within that application, you now have a solution. You don't have to come at it from an imperfect solution where you're polling the functions and trying to make sure that they stay up on a fairly good interval. So so Amazon has again heard the problems from the user community and really stepped up to say, okay, we're going to offer you a solution. We're going to make some money off of it, of course, but we will make sure that this is something that isn't going to hold you back and isn't going to be a problem with our product. So in addition to the 6 we see here, PowerShell was added since I originally gave this presentation, and also Rust and C++ are in the pre-release phase currently. And one interesting thing to note is you can build your own runtime in C++. So if you have the aptitude and you have some spare time this weekend, you can just code till your heart's complete and make your favorite language AWS compatible in an unofficial sense. So when looking at the Lambda function, what are the pieces that we're looking at? So first thing is what we just discussed, the runtime. So which language are we going to be running this in, whether it be Node.js, Java, Go, Ruby? So we have to settle as a development team on what makes the most sense to adopt, and potentially you could have functions running in different technologies. Depending on your team, that may be the worst idea in the world, but the capability is there for you if you were running in, say, a multi-language type environment. The handler is what you would normally think of for a function. It has an event, has a context, has a callback. So pretty standard things that all developers are used to. And then we have our trigger. So what is actually firing this thing off? As we discussed, it could be, say, a DynamoDB table is updating. We can tap into that stream and see when that happens and kick off our Lambda function. Possibly it is a cron job that's running from CloudWatch events, and that kicks this off at a regular interval. Or probably the most common use case I can think of would just be an HTTP request, coming in from an API gateway that triggers that code off. So lots of different ways, and again, there's probably 30 different AWS services that work with Lambda. So there's so many different use cases that we can really tap into to make Lambda work for us. So when we look at the overall picture of how this comes to be and how this works, we are looking at basically when we create a Lambda function, we have to tell AWS that we require this much RAM and this much CPU capacity for our function to work. And we do that that's modified on each different function that we load up and we create. So in doing so, when our trigger is made to the function, AWS says, okay, well, I know what to do with this. It's going to, basically grab a container to run this function in. It's going to allocate that necessary RAM and CPU capacity, and within that multi-tenant cluster, it's going to fire this off. And what it's doing behind the scenes on the pricing side of things is it is looking at that RAM it's allocated and how long this function spent executing, and based off of those two pieces of calculation, it's saying, well, this one function costs this many millionths of a cent or whatever. So, and that's what becomes your bill at the end of the month. So that is basically the cost matches usage model that we discussed earlier in a nutshell. And that's how they kind of comprise it within that container setting. So in looking at pricing, our standard pricing is what we originally mentioned. And so now we have this new model, this provisioned concurrency pricing. As you can see, it's slightly higher, probably about double on the gigabit per second. Our requests are the same. And then we also introduced the duration, or excuse me, the duration side is what is that? A little bit higher, and then we also add the provision concurrency cost for every gigabit per second as well. So depending on your needs and depending on what you need for your user base and how much tolerance they have for downtime and lag, this may be very important for you. There are other ways to come at this, as we've discussed, but this is the kind of official solution if that is a concern. We've discussed that there are 30 Lambda service or 30 AWS services that work with Lambda. So everything from DynamoDB to S3, Alexa, and API Gateway and CloudFront. Really everything that you could potentially want to plug into this thing, you can. It's kind of interesting when you have all these fun tools at your disposal and you're putting together a new system that normally you would go out and say, well, I need a way to solve this problem, and you kind of go out to the community and find some third-party software or something to fill that need. But instead, you kind of start with AWS and say, okay, well, does AWS have a service that, an email service that I can tap into to handle that, instead of having to, go with SendGrid or some other outside service that I have to tap into from AWS. It's already included in my suite, so it really allows you to tap into and take advantage of all the benefits that the cloud brings you, instead of our more traditional model of just figure it out from what's out there. So that brings us to the companies that are using Lambda. So I've grabbed 4 from their examples that I feel represent Lambda usage in different ways, and how they come at things is unique. I felt like there was something to be said for each one of these. 3 you've probably heard of before, and then Financial Engines is kind of a lesser known quantity, but they have the cost model perfected. So I definitely wanted to include them to see what was possible from that side. So Netflix, no introduction needed here. The really interesting thing I thought was that they serve up 7 billion hours of video to 50 million customers across 60 countries. So Netflix is huge, but putting those numbers into perspective is pretty mind-boggling. And the thought that they have turned to AWS and Lambda to help make that whole engine work is a huge endorsement for Lambda and what is possible. So particularly what they were looking at was they needed help to automate the encoding of their media files, to validate backup completions, and to deploy instances at scale. So Via Lambda, they developed this rules-based self-managing infrastructure, and through that, we're able to gain a lot more efficiencies, cleaner logic, and able to really maximize their processes. And interestingly enough, I used to have a slide before I packed more content in here. That was I think it was their either the chief technology officer, or chief innovation officer, talking about why Netflix chose Lambda and what benefits that it brought to them. And it's out on YouTube. It was a reInvent conference, but it's a really kind of interesting take from them directly as to here's the problems that it helped to solve, and here's why we really wanted to adopt Lambda. So a huge win for the AWS team getting Netflix on board with this process. So iRobot, for those who aren't aware, probably you are aware of their most popular product, which is the Roomba, the automated vacuum cleaners that run around your house and pick up after you and pick up after your pets and all that. When looking at the IoT space, they have sold 20 million units, which every single one of those units is continually sending data back to main headquarters. And so iRobot had to deal with this massive influx of data. And in particular, their highest volume is when a new unit comes online. We got to register that unit. We have to get them into our system. From that, they had a particular need that they released the Roomba, I think it was 5 or 6 years ago during an Amazon Prime Day, and saw they were one of the featured products, and the demand went through the roof. They sold like 5 times more than they ever had before. So they had an immediate need. We have to solve this problem yesterday of how we're going to handle all these new units coming online. So they turned to AWS and to Lambda to put together a serverless architecture to handle this influx of traffic. So through this, they have 25 different services that run a Roomba vacuum, which is interesting. They're really tapping into basically everything that AWS has to offer. And through that, they're able to keep the cost of their cloud platform really low, avoiding the need for subscription services. And they run that whole thing through fewer than 10 people. So it's impressive. And this is, even though we're talking about iRobot and Roomba, this is a huge need that is on us, and the IoT spaces are just exploding. There's 20 billion connected things in use worldwide as of this year, according to Gartner. So it is impressive to see what Lambda can do on the IoT side of things. So this next slide shows us a quick take of what this might look like from an architecture standpoint. So we have our Roomba device who calls into the CERT API, which then contacts our Lambda and interfaces with the IoT and writes to our CloudWatch logs, puts a message on the SQSQ, and then once it goes to actually register that robot, 2 Lambda functions are checking with the IoT rules, as well as verifying the policies and making sure that everything kind of lines up and functions well. Again, this is kind of a simplified look at what this process looks like, but you can see where Lambda falls in it and how it facilitates all these other services, and how this workflow really is very smooth and all works together and handles problems very well. And basically, that automated workflow makes sure that no one else is actually having to step into this process to kick anything off or do anything manual through that. So that brings us to financial engines. Financial engines is you could look at them as like an AI source for automating investment portfolio management. They serve 9 million people with 1.2 trillion in assets. While they may not be a household name like the rest of our other 3, what I found hugely interesting was they were able to save 94% in hard costs by going to serverless and to Lambda. which is huge. I mean, if you go to your boss and say, I've got a solution that can save us 94% on our hard costs, I think you don't ever have to worry about job security ever again. So again, this is not, I don't want to say it's the exception, but not all systems are going to fall into this camp. But there is the possibility that there could be significant cost savings by going to a serverless solution. So for financial engines, they were able to replace 50 of their IPO servers, and IPOs really has nothing to do with IPOs, just how they refer to their servers. But they were running on 21 different environments, and they were able to break all that down into 4 Lambda endpoints to handle all that traffic. And we're talking, 200 a month. It's at the highest time, the peak traffic times, we're talking 60,000 per minute, which can be 10 times higher than usual. And the real kicker behind that is they saw near zero downtime, near zero performance degradation. So even with that huge cost savings, they didn't really give anything up on the for availability and for performance by going that route. So that's pretty impressive. And then finally, The Guardian. They are a UK news provider. They also, The Observer is under their umbrella. They serve 60,000 people worldwide daily, receiving their paper. And they had a very interesting problem. So for them, they had all these disparate databases that had pieces of customer information, but they didn't have the full picture. So one might have the customer details, one might have subscription information, one might have delivery details or something else. So none of these databases talk to each other. It was all kind of a mess. So I order my paper on a Monday, and I might actually receive the first copy on a Thursday. So that's pretty unacceptable in today's world. And it goes the other way too. Say I cancel my paper on Monday, I'm still receiving it till Thursday. So now the Guardian's losing money sending out papers that really shouldn't be going out. So they used Lambda with step functions, basically workflow automation, to make all these things talk to each other and to smooth out this process so that when I order my paper on a Monday, that I get it on a Tuesday, and there is no lag, there's none of this chaos happening behind the scenes that the customer is really unconcerned about. They just want their paper. So again, kind of looking at this from a very high view, the step function facilitates triggering that Lambda function, throws a file over onto S3 or updates something in S3, which then contacts another Lambda function, which kicks off the Salesforce delivery, which sends the truck out to get you your paper at the house. So, so 2 more slides before we get to our demo. 2 things that we definitely don't want to overlook. We have been fairly positive on all things serverless. So we want to try to round things out for awareness sake to say that there are some limitations to serverless, and there are some traditional concerns around security that we already have. It's just they're a little bit different in the serverless space. So when we look at security, to start with, we want to make sure we are practicing least privilege. So if we are releasing a Lambda function, we are giving it access to do exactly what it needs to do and nothing more. We never want to open up, admin access and allow it to have run of our space. Again, these are things that we deal with in a on-prem environment or a traditional application situation. We want to still protect against event injection, whether that be validating our input logic, using stored procedures, ORM, things of this nature. So that hasn't changed. We still have to, being in the cloud doesn't magically solve our ails in that. But one that's very interesting is DDoS attacks. So if we remember back to our cost matches usage model, DDoS should be a huge concern for us because within a couple minutes, they can bankrupt us, with the volume they are hitting against that function or our suite of functions. So we can use something like API Gateway to stick in front of those functions to mitigate that impact. And basically, once it sees that we are getting flooded with traffic. Okay, we're gonna shut this thing off. Something is clearly going wrong, and somebody needs to intervene and look at this situation before we're just going to allow this just to flood through. Which is where monitoring and logging come in. You know, we really need to make sure we've set that up appropriately so that when these type of events happen, we need to make sure all the key players are aware that, you know, something out of the ordinary is going on. So maybe it could be completely reasonable. Maybe it's a Black Friday type event where we're expecting, if we don't get a flood of traffic today, then something's hugely wrong. But if we give that alert, then we're like, okay, yeah, this makes sense. We're expecting that. But on a traditional day, we need to get ahead of it if there is you know, something going on that we weren't expecting. So also we need to patch dependencies within our application. So we discussed that we don't have to worry about patching the OS, but we do have to handle the application level. So if you know, new updates to our packages and things that we're using within our application are out there, we have to stay on top of those. AWS is not magically waving a wand over our application and handling it. So, and also we need to make sure that we are securing those keys. We don't want to just have them out there for the world to see. And so that's obviously a huge concern in the cloud space, is making sure those vulnerabilities aren't exposed and that we are handling things in the correct fashion. So if serverless is in your future, I really suggest digging into the security side of things and making sure that you have everything locked down appropriately so that you don't have any gotchas after the fact, and you're kind of left wondering, well, nobody ever told me about that, and I didn't know that was supposed to be a concern, because in our traditional on-prem environment, we never had to worry with those kind of things. So some things you do and some things you don't. Some things are kind of introduced via being in the cloud. So something to be aware of. And finally, limitations for serverless. We discussed the factoid that it's not necessarily cheaper. It can be, but the onus is on you to do your research. There are some nice tools out there where you can calculate, you know, how much traffic gets into it, and you know, what does our normal daily volume look like, and you can back into this without really having to do a whole lot of heavy lifting to figure that out. But you still have to do the work, and you still have to do that research. Loss of control is a concern. You are, as I said, you are not managing the hardware. You're not managing the infrastructure. You are handing that over to AWS and say, here, this is a headache. We don't want to deal with this, and we have certain events from our organization that make this very difficult for us. So we want you to manage this. And in doing so, you are surrendering some of that control that you would normally have. So if that is a problem for your organization, you need to kind of do some real think about it and make sure that that's the right solution for you to hand that over. Vendor lock-in, which is kind of a more of a cloud type limitation than it is for a serverless, but serverless goes along with it. So if I make my commitment to AWS and we're a year into this project and we decide for whatever reason it's just not a great fit, it's hard to just say, well, okay, we're just going to switch over to Azure. You know, we've just like any application development, you've spent an entire year dedicating yourself to this technology, to this vendor. It's now extremely difficult to change horses midstream and go with something else. Not to say that it can't be done, but it does add a lot of complexity to your project and to your system. So it behooves you to do a lot of research on the front end before really dedicating and locking in to say AWS or Azure or, you know, whatever your cloud provider is going to be. Conversion to serverless can be a little bit painful. We just kind of discussed that. If you have an existing system you've been working on for 4 years, moving to serverless can be a rewrite in a lot of cases. It can be starting from scratch and piecing things together in this new architecture and this new model. And it definitely works better when developing a new application, but you can convert over existing applications, but there are some challenges there that you would have in really any time you make a major technology change within an application. really the nature of things these days, we have more complex architectures. We have with serverless, we have, there are event-driven applications, asynchronous messaging. They are stateless, so we have to store that state somewhere, whether it be in S3 or DynamoDB or someplace else. So we need to wrap our mind around how to think about this architecture with this new technology. So again, it's just a different way of thinking about things and being comfortable with that. And then debugging can be a challenge at times. They do have tools like X-Ray that you can kind of step through, but it does seem to be getting better, but it does have its challenges that we don't necessarily have within our space currently. So that ends our slides. So again, I wanted to show you two quick demos, and let's find our other screen here. All right, so now we should be seeing our Visual Studio. So the two quick demos we're going to look at is how easy it is to get up and running with Lambda if you are a Microsoft developer. So this could be if you're running in C# or if you're running Node.js. Both are kind of inherently supported through Visual Studio. And to get started, really all you have to do is come up to extensions and do manage extensions. And from the Visual Studio Marketplace, you'll just search for AWS. And you'll see the AWS Toolkit. As you see, we've already have it installed here. One thing to note is that it is only supported for Visual Studio 2017 and 2019. So if you haven't upgraded, this is a perfect reason to step up. I've been using 2019 very exclusively lately, so it's nice some of the new features they have. So once you do this, and you would do install, it's going to run through its process of creating that new application, and then at that point, you will now have new product options. So if we type in AWS, hold on, back up. Let's see here. So we have like our serverless application. We have an AWS project with tests, F#, C#. We have a lot of different options that AWS gives us out of the box with that toolkit. So let's go ahead and select the C# project with tests and do next. And let's name this thing something unique, so I know that we haven't created it in the past. And next we're going to see our blueprint. And I mentioned this before. Blueprints are basically a way to get up and running quicker that AWS has provided for us. So we have things like we could create a chatbot. We could do a simple DynamoDB function. For us, we are just going to choose the empty function just to get us started. And that creates our project, which will come up here in a second. And so we have our little test suite here. But what we are concerned with right now is these three files that is created for our standard project. Our README file is going to be lots of stuff that we have talked about today. Just the basics of getting up and running, using Lambda, things that are helpful to know. So if you're looking for a quick refresher, that is a great place to go to kind of use that as a springboard to get started. If we look at our JSON file, this is all of our settings that we are defining for this function or for this project. So we're defining, what region do we want this run in? US East is our default. What version of .NET Core do we want to use? Right here, we define our memory size. What is our timeout going to be? We'll see this again once we go to publish our function, but this is an easy way to go in and get all that stuff set up before we actually have to step into it. And then finally, we have our function file. So for today, we're not going to do some code wizardry or anything else. You guys all know how to code. Our goal here today is just to show you how to get started and how easy this is to publish a function once you have created it within Visual Studio. So our function here that it creates for us is just a little to-upper function. And so nothing crazy, very basic. So if we right-click on our project here and select Publish to AWS Lambda, we now get our upload screen. So the first thing we want to do is set a profile name. We need to grab our access key and our secret key from AWS, as well as our account number. And then once we have all that and save it out, we will have an account that we can publish to. And if we look down here at our options, it's asking us about what kind of runtime we want to use, which version of .NET Core. And as I said, we don't have to use .NET Core. We could be using Node.js as well. We need to define our function name. So in keeping with our project name, we're just going to call it test function 77. And from there, we can go to our next screen. And here's where we saw that we can also, outside of the config file, we can set our memory, our timeout, that sort of thing. The key thing to know on this screen is our IAM role. So what role are we going to, what permissions are we going to give for running this function? So you can either go into your AWS console and set up an IAM role, or you can grab one of the existing ones to create a new role. For our purposes, this my Lambda execution role is one I've already set up in the past. So we're just going to use that because we know it has all the permissions that are needed to run this, but nothing past that. So finally, we're just going to hit upload. And we can watch the process as it actually throws those files, basically zips them up, throws them up on AWS, and gets us ready to go. And so now our function is in AWS. As long as my session is still logged in here, we can see that there's our test function 77. It is there. And just to kind of show you what it looks like on the other side, we see that from there we can also define the runtime and set up monitoring tools, and we can go a little bit in further depth that from Visual Studio that we couldn't. There's our concurrency model if we wanted to set that at the function level. So lots of additional stuff that we can configure within the console, but Visual Studio gives us a great way to get up and running quick. So just to verify that we are working, let's type in our name in all lowercase to invoke that function. And as you saw, that took what, 400 milliseconds to come back. So not a whole lot of going on with that function. So it's pretty lightweight, but response time was pretty good. But that is a cold start. And the interesting thing to know about here is it shows you the duration, what it took, how many milliseconds it took, what was our build duration, our memory size. We already allocated that to 256, and what was our max memory used was 66. So we might look at that and say, well, maybe we can scale that back a little bit because we're not actually using all of that space. So maybe maybe something a little bit lighter might be more appropriate. But this is a nice, helpful way to kind of back into, okay, what does our cost model look like per transaction through this? So that is Visual Studio, and we are running a little thin here on time. I'm going to see if we can walk through this, but before we get to that example, I do want to bring up this, which is the GitHub repository for serverless.com. Serverless.com does a lot of reporting on what's going on in the serverless space, regardless of vendor. Pretty cool publication. If you are interested, I would definitely recommend checking them out. But once you go to github.com/serverless, and I will have a link to this in the slide deck if you want to reach out to me for that, you hit the examples button or a link, and then from there you see all of these various things that you've got out of the box that you can start just playing with AWS Lambda. I mean, everything you could ever imagine as far as creating a Alexa skill with Python and and really all different languages, Go and Node.js, and there's a Twitter joke bot. I mean, there's all sorts of different possibilities, and there's more down here. So my recommendation would be to come here and just kind of peruse and see what's out here. And the nice thing is you can just download it to your local, that code, and trigger it. For our example, we are going to use a REST API written in Python, talking with DynamoDB, and it's super easy to get up and running. So we have already changed directories into where that project is located. So the first thing we want to do is we want to install Serverless through npm. And I'll take a second to run through its process, but it is fairly quick. And then next, so we've got it, we want to deploy that serverless product or project up to AWS, just like we did in Visual Studio. But we're going to do everything through the command line for this. So as we can see, our serverless framework was successfully installed, and we are ready to run our project. So to get this thing deployed, we just need to come in here and do a serverless deploy. Excuse me. The first time you set this up, it is going to walk you through the steps of, okay, what is your secret key? Just like we saw in Visual Studio. I need to authenticate that you are who you are and that you have access to load stuff up for this project. But since I've already set it up, it's just going to run through and say, I've got all the credentials that I need. I'm just going to start packaging the service up into a zip file, throw it up to S3, and then from there, it will allow us to create that serverless project in AWS. So again, that takes a couple seconds to finish its upload. All right, great. So now we see from that, we have a series of endpoints. We have a post, we have a get, we have a get via ID, we have a delete via ID. And this little mini project, if we go to Postman, and since I've already loaded this one up before, you'll see that my endpoint URL is the same as what it has provided for us. So no smoke and mirrors there. It's just we're reloading the existing project. So from here, we see this is kind of like a library type project or a bookstore or something. If we do our git command, it brings us back all of the books that are in our library, mad about Python, learn JavaScript in 15 minutes or less. And from there, we can do our post to add, say, the hidden tricks of AWS Lambda, and throw that into our library. And now we have, I think I actually already had that one already in there, but we have our new book within our bookstore. So again, real quick and easy to get up and running. You can jump into those code files and get started pretty quickly. But I just wanted to show you those resources that were out there because they are hugely helpful to get up and running. So to wrap us up here, let's get back to our slide screen. All right, and let's move that away. So at the end, I believe we are going to have the video posted online, but the slide deck we will not. That's interesting. I'll have to clean that up. But something to know is that everything here was done through the AWS free tier account. So sign up for the free tier account, play around with all the Lambda stuff that you want to. You're not going to get billed for that first year unless you just really go crazy and max this thing out. So check that out. Definitely helpful. This third one is an article I wrote after giving this presentation that kind of lays a lot of this stuff out and goes into detail about what we talked about today. The last two are the serverless examples we went through from on GitHub, and the last one is the FAQ from Amazon. It will answer pretty much anything you ever wanted to know about Lambda and in minute detail. So a great resource to have in your back pocket to go back to whenever you have Lambda type questions, or what are my Lambda possibilities? You've got to go through and see, okay, well, I didn't realize I could do that. That's pretty cool. So that wraps us up. Thank you all for joining us today. I have listed my email here, mark.runyon@improving.com, if you want to reach out to me. I'm happy to take questions now, but if you have a question, say, tomorrow or next week or a month from now, please reach out. I'm happy to discuss anything around serverless or Lambda in particular. Also, I will be posting the slide deck to my Twitter feed, which is ASP Programmer is my handle, and I would love to link up with all of you on LinkedIn. So I am at handle software architect. So thank you all again, and I will hand it back to Will.
Great. Thanks, Mark. So we are actually out of time. So we do have a couple of questions. If you feel like those questions have not been addressed already, feel free to email Mark directly, as his email is already listed there. And other than that, we thank everyone for attending Improving's Virtual Lunch and Learn. The recording of the session will be available tomorrow from our virtual events page and also our YouTube channel. We hope you enjoy the rest of your afternoon.